Hello everyone, we are the USBridge team. Today I want to take a closer look at the device itself, its architecture, how it works, and its key features and capabilities. Let's start with the basics. USBridge is a hardware KVM. Unlike software solutions, the device works directly with physical interfaces. We use HDMI for video signal capture and USB for keyboard and mouse emulation. To the target system, USBridge looks like a standard monitor and keyboard. No need to install any drivers. No agents needed in the operating system. You get full control over the hardware at all stages, from a cold boot and BIOS setup to remote system reinstallation. Essentially, it's your personal IPMI for any hardware without a built-in management module. An old server, a workstation, or a custom build, now you manage them remotely at the hardware level. This is what the USBridge device looks like. It has everything you need on board. USB-C ports, 8-pin connector, and SD card slot for data storage. There's a display on the front panel. It's used for monitoring and quick setup. For navigation, we've added a joystick and function buttons. The menu has everything for full operation, mounting images and managing snapshots, viewing logs, settings, and monitor mode. We've tried to make the interface as clear as possible, but let's go through everything in order. Let's move on to the physical setup. We intentionally designed the connection process to be as simple and intuitive as possible. Look, I'm connecting the USB cable now. It serves both to power the device and to emulate a keyboard and mouse. Next, I'm connecting the HDMI cable directly from the target machine. Our network connection is handled through Wi-Fi. For this example, I'm using a standard motherboard based on the X99 chipset with a Xeon processor. Typically, these boards don't have a built-in management module. Once all the cables are in place, the device is ready to go. No complex initialization is required. During the development process, we came to one very important conclusion. Most KVM devices simply stream a video feed. This is a time-tested standard, but for automation, it's just not enough. In USBridge, data from BIOS and UEFI is output directly to the terminal as plain text. This approach opens up completely new possibilities for administration and process automation. Here, I'm connected to the KVM through a standard SSH session. Video conversion happens offline on the USBridge device itself. It doesn't send any data to services or the cloud. This makes the process fast, secure, and suitable for working in isolated networks. We've also implemented a caching system that makes interaction responsive, and the resulting latency is minimal. As a result, BIOS becomes more than just an image. It's readable data. You can copy it, search using grep, and use it in automation scripts and agent workflows. Let's break down what a snapshot is. To put it simply, snapshots are an instant picture of your data. Unlike regular copying, which can be accidentally deleted or corrupted, snapshots capture the state of files at a specific moment. Everything in a snapshot is like it's carved in stone. This data isn't going anywhere. For you, it's an absolute point of return. If you accidentally delete an important project or a virus encrypts your files, you just roll back time. A snapshot allows you to return to the state when everything was working perfectly. Essentially, it's your insurance against any errors or software failures. You always know you have a clean copy, protected from any changes. On the right, we have the USBridge client application open. We are currently in the Snapshots tab. This shows the current state of the device's flash memory and a list of available snapshots. Now I'm opening the USBridge storage media itself. To the system, the device appears as a standard external drive. Now I'm adding a test file to the USBridge system. This change will go into the current flash state and then be captured as a snapshot. We can see that a new snapshot has appeared in the list. The system has captured the flash memory state with the added file. Now let's add another file to the USBridge drive. The current state changes, but the previous snapshot remains untouched. This is the principle of versioning. Each point is captured separately. Now we already have several captured versions. Each snapshot is displayed with its creation date and time. It's a specific point in time. Now let's try to delete the files from the USBridge drive. As you can see, the files are deleted and the drive is now empty. After deletion, the system automatically creates a new snapshot. Another entry appears in the list with the current date and time. This is already a new version, an empty drive. Thus, even deleted data is captured as a separate point in time. Now let's mount the first snapshot created and see what's inside. I'm selecting the earliest recovery point, and we see that the first file is there, even though the current drive is empty.
In this snapshot state, it's the saved version with one file. Now let's mount the second snapshot, the one where we already had two files. We open it up and we can clearly see the drive in exactly that same state as before. And finally, let's go ahead and mount the very last snapshot, which accurately reflects the empty drive state. When we look inside, we notice there are absolutely no files present. This is an exact copy of the moment when the drive was completely cleared. And let's also look at the detailed information for the snapshot. The window displays the creation date and time, as well as the list of changes captured in this version. We can see which files were added, what changes occurred, and exactly when it happened.
You can also view existing snapshots on the USBridge device itself, as well as mount them directly from the device itself. We use BTRFS as our file system. This is a fundamental choice because snapshots here operate at the block level. We don't copy files the old-fashioned way. We use a copy-on-write mechanism. We only save the delta, essentially specific file changes, rather than everything. We don't need to duplicate information when creating each snapshot. This not only saves storage space, but also significantly speeds up the process. This enables data recovery after incidents, as well as offline recovery in isolated networks without using the network or cloud services. Our snapshots are mounted in read-only mode. What does this mean in practice? They are accessible for viewing only. Neither the user, nor an application, nor even root on the target machine can overwrite, delete, or corrupt them. Even if the host machine is completely compromised, we are confident that the data history will remain untouched. This is your digital safe. We have provided flexibility in data storage, allowing you to use just about anything you like. Regular flash drives, microSD memory cards, or even external solid-state drives connected via USB. We do not utilize any proprietary format, so you can simply mount your media on a standard Linux system and easily and conveniently view your data without a USBridge device or any specific software. For us, snapshots aren't just some feature, they're the foundation. This is true trust in the system. USBridge is a classic KVM. You can also use video mode if the UEFI is graphical or if you just want to see the image as it is. A single cross-platform application is used for operation. It works on Linux, macOS, Windows, and on any mobile devices. Let's take a closer look at the application itself. With its help, you can manage sessions, mount ISO images, watch video, and connect a keyboard and mouse. Everything is like a standard KVM device. You can also turn the remote machine on and off. A separate point, USBridge can act as a network bridge for the host. If there's no internet on the machine, the device can pass the connection through itself. This is convenient for initial setup and recovery. USBridge can also be used simply as an external monitor for diagnostics. Connect the power and HDMI and you can immediately see what's happening. It's needed to quickly understand if there's an image and where the system hangs. Give it a like if you enjoyed this video, and write in the comments which workflow scenarios you'd like us to cover in future videos.